This prototype is a crucial component of the system. It is acting as the front door to robust 6G security capabilities. The NetSecaaS gateway is a governed, developer-friendly service layer. It exposes security outcomes through developer-friendly APIs, while exploiting the platform data layer, policy enforcement, and orchestration layer. Third parties with this gateway discover capabilities and request protection without interacting directly with the internal components. NetSecaaS offer to consumption patterns, governed data retrieval, and high-level customized action trigger. Architecturally, the gateway is the exposure boundary of the robust 6G platform. CTIDO3 is the only externally visible component from a third party. Everything else stays hidden behind governed APIs. It bridges consumers with data management and zero-touch security, offering a single integration point for XAI reports and Defender actions. Let's walk through the retrieval flow. CTIDO3 delegates the access decision to data governance. The request is transformed into a Sparkle query and resolved against the knowledge graph. Only the authorized subset of evidence is returned to the consumer. Now we can analyze the configuration flow, turning intent into enforcement. The request arrives as a concise REST call. Data governance validates identity and entitlement before any orchestration artifact is created. The transformation function converts the intent into an SSLA, and the security orchestrator executes the action. The prototype has for cooperating layers. The northbound interface exposes Kamara-style REST endpoints, protected by OAuth 2.0. The transformation function maps REST parameters to Sparkle, SSLAs, and policy checks. The data management platform handles semantic storage and authorization, and the security orchestrator executes the actions. Regarding the security data exposition, the data fabric is a crucial component. It is the ingestion backbone. Data fabric manages the incoming data flow through three kinds of entry points: HTTP push, MQTT streaming, and REST pull. At each entry point is associated an RML mappings to lift, i.e. transform raw payloads, into RDF triples. Then the structured data are persisted in GraphDB. New sources of data are added by defining mappings and associating them to the corresponding data source, not by developing custom code. We validated the gateway through use case 3. Across 3 flows: capability discovery, XAI data exposure, and SSLA enforcement. Every flow passes through CTIDO3 and data governance. Flow 1. Security capabilities discovery. This is how a third party finds out what the platform can actually do for them. Step 1. A third-party consumer sends a request to CTIDO3, the NetSecaaS gateway. They're asking, in Kamara-style terms, which security capabilities they're entitled to see, what state those capabilities are in, and which parameters they can configure. Step 2. CTIDO3 does not answer on its own. It delegates the decision to CTIDO2, the data governance plane. The transformation function maps the incoming request into a query against the access policy catalog, and CTIDO2 evaluates the requester's identity and entitlements through the policy decision point. Step 3. CTIDO2 returns the filtered subset of capabilities, only those the requester is authorized to discover at the granularity the policy allows. Step 4. The gateway delivers that catalog back to the consumer in a single, user-friendly response. Authentication and audit are enforced transparently at the API boundary. The consumer never touches an internal component. Flow 2. XAI Analytics Data Exposure. This flow exposes the explainability reports produced by the platform's AI-driven security services. The flow has 2 phases. Phase 0 is offline and continuous. The XAI services, CUCDO2 and CEPIYO3, analyze raw security information, produce detection or prediction outputs together with their explanations, and push both into CTIDO1, the data fabric, through declarative ingestion. Over time, this builds a knowledge graph of SHA-enriched security data, ready to be queried. Then the online phase begins. Step 1. A third party submits a request to CTIDO3, typically specifying an attack type or a time window of interest. Step 2. CTIDO3 delegates authorization to CTIDO2, the data governance plane. Step 3. Once authorized, the transformation function maps the request parameters into a Sparkle query, and CTIDO3 issues it against CTIDO1, the data fabric. Step 4. The data fabric returns the matching subset of XAI-derived security data from the knowledge graph. Step 5. CTIDO3 delivers the analytical results, together with the explanations that justify them, back to the requester. So the consumer gets not just the conclusion, but the reasoning behind it. Let me show you this one in action. First of all, I show you how the stored data are structured. Here you can see the ontology governing the data. Before phase 0, no data about the XAI are stored in the database. To set up the pipeline, we go to the data fabric, and we upload a mapping for each of the data source. CUCD02 and CBY03. Then we set up an MQTT hook for each of them to recollect the data and apply the corresponding mapping. Now I run a simulation to produce data, publish them on MQTT and trigger the pipelines. Here you can see that Dagster is queuing all the incoming mapping requests and sequentially elaborating them. Finally, here you can see the data reflected in the GraphDB. To test the online phase, I play the role of a third party asking the gateway for explainability reports. We'll watch the authentication request to prove that all the interaction are secured with OAuth 2.0 authorization, and then see the data retrieved. Flow 3, Simplified SSLA Enforcement. This is the configuration direction of the gateway. A third party doesn't retrieve data, they ask the platform to do something. Before the flow runs, a baseline set of reference controls, drawn from NIST SP 853 Revision 5, is already loaded into the data fabric, available as a reference for the transformation function. That's the 0-numbered step at the bottom of the diagram. Now the live flow. Step 1. The third party sends a high-level intent to CTID03 using the available controls and metrics, NIST compatible. Offered by ZTSO, no low-level configuration, just the desired outcome. Step 2. CTID03 forwards the request to CTID02 for authorization. If the decision is negative, the flow stops here with an access denied response. And no SSLA is ever generated. That's how the orchestration plane stays protected. Step 3. On a positive decision, the transformation function converts the intent into a structured security service level agreement. ANSSLA capturing the parameters and constraints of the operation. And CTID03 forwards it to CTHL01, the security orchestrator. Step 4. CTHL01 interprets the SSLA and executes the corresponding actions on the underlying robust 6G security capability CRG00. coordinating with CNX W01, the zero-touch security orchestration plane, for any closed-loop activities. Step 5. Once enforcement is complete, CTHL01 returns the execution status back to CTID03. Step 6. CTID03 delivers a simplified, consumable response to the requester. A single API call, and the platform has taken responsibility for translating it into real, orchestrated security action. Let me show you this one in action. First of all, I show you how the stored data are structured. Here you can see the ontology governing the data. The first ontology refers to the NIST data. As to see the ontology is structured in order to semantically consider the NIST control as a security control in the scope of ZTSO. Here you can see the entire view of both ontologies to see the relationships between them. To test the online phase, I play again the role of a third party asking the gateway for the available security controls and to generate an SSLA. We'll watch the authentication request to prove that all the interaction is secured with OAuth 2.0 authorization, and then see the data retrieved. To close the prototype description, this slide shows the deployment details. The Telefonica testbed hosts the gateway, the data fabric, data governance, and the XAI services. The NextWorks testbed hosts the security orchestrator. The interconnection between the two testbeds is not currently live. Instead, it was validated through a series of offline, asynchronous tests that exercised the same message exchanges that confirm the feasibility of the integration. The key takeaway is this: NetSecaaS turns robust 6G security into something developers can actually consume. They request outcomes through a single, intent-oriented API, and the platform handles data, policy, and orchestration behind it.